And all right, good evening, everybody. Welcome to tonight's seminar. For those who have not yet had the opportunity to meet, I'm Doug Zemeckis, the Marine Extension Agent with Rutgers Cooperative Extension. Thanks for joining us tonight. Tonight is number 6 of 6 in our All the Small Things with Big Environmental Impacts seminar series through Rutgers Cooperative Extension, where we provide science-based educational programming to improve the quality of lives, businesses, and communities throughout the state of New Jersey. This seminar series has been a collaboration between 2 extension programs, the Earth Day Everyday program, and also our Marine Extension Program seminar series. I'd like to acknowledge my collaborators on this All the Small Things seminar series, Steve Yerjo, Amy Rowe, Sal Mangiafico, and Michelle Bacchus, other extension agents with Rutgers Cooperative Extension. And we sought, and tonight is number 6 of 6 in these seminars, to provide science-based information looking at small substances or changes that can have big environmental impacts here in New Jersey, and what individuals can do to be more environmentally responsible. We looked at topics such as beach leaf disease, microplastics, bioremediation with bacteria, and also quite a bit on water quality and harmful algal blooms more recently. And tonight we'll continue along those lines with Bob Schuster from DEP. Some navigational aids for tonight's webinar. We have about an hour plus as needed to go through Bob's presentation. We'll take question and answers about halfway through and at the end. The chat feature is disabled for participants tonight. If you have a question, please use the Q&A feature as opposed to the chat. I'll be moderating and we'll go through as many questions as we can for Bob halfway through and at the end. And we are recording tonight, and the recording will be posted in a few days on the Earth Day Everyday webinar series website, where you can also visit webinars from others programs that have been hosted through this program for the last several years since the beginning of COVID, and covering a wide range of terrestrial and marine environmental topics. With that, towards the end of tonight's seminar, my colleague Amy will start a poll at the end of Bob's talk. That poll will be an evaluation survey, so you can provide your feedback on Bob's presentation tonight, what you learned, and some of the changes and increased knowledge you might have gained from tonight's presentation. That evaluation form is viewed as research by our institutional review board. As a result, the first question in that poll will be your consent to whether or not you wish to participate. And you can stop at any time when you're filling out that short evaluation. But we appreciate all the feedback you can provide on tonight's program, so we can improve this and other programs we offer through Rutgers Cooperative Extension. Also, Rutgers Cooperative Extension, we are an equal opportunity program provider and employer, making educational programs available to as wide of an audience as possible. Example, this Earth Day Everyday and MEPS collaboration, having these live webinars and the recordings to make them as accessible to serve a wide range of clientele without discrimination through New Jersey. So thank you everybody for joining us. With that, I'll stop sharing and pitch it over to Bob to share his screen while I also formally introduce him. Our presenter this evening, featured speaker, is Bob Schuster. He's the Bureau Chief of NJDEP's Bureau of Marine Water Monitoring, where he has many responsibilities, including the oversight of all of DEP's marine water quality monitoring throughout the state of New Jersey, from sample collection, lab analysis, and data interpretation and assessment. He's got over 30 years of experience in these fields of sampling, chemical, biological, microbial analyses in the lab. He's always been a valuable partner and contributor to many of our working groups and research projects through Rutgers, and our education outreach programs through Rutgers Extension. Tonight, he'll be speaking about the work that he and his team are doing to monitor and preserve the ecological and public health of New Jersey's marine waterways. Bob, thank you very much for joining us, and I'll turn it over to you.
All right, great. Thanks, Doug. Thank you for having me. I'm glad to do this. I've been doing this a lot of years now. I was looking back at how long this goes back, and I'm happy to do it. Always look for opportunities to talk about marine water monitoring, what we're up to and what we do. Going to start with the background. Our bureau, I'm the Bureau Chief of Marine Water Monitoring. We're located in Atlantic County. We have a lot of different components to our operation. So we operate multiple laboratories. So we have laboratory staff doing analysis. So we do phytoplankton identification. We do ambient marine water monitoring. That's a lot of nutrient work. We do Vibrio analysis in our lab. We do a lot of special techniques for source trackdown, antibiotic resistance. We use qPCR, we use mouse-specific colophage, and then we do the traditional indicators. We also do assessments of water quality. We've worked on ocean benthic index over the years. We've worked extensively in the Barnegat Bay with starting back, 30 years ago, but more intensively over the last 12 years with intensive Barnegat Bay monitoring, working with science and research throughout the whole department to develop better tools, looking at nutrient impacts. Our main goal is shellfish water classification, which I'll talk about. But we also have field staff collecting those samples for various, studies, routine plus pollution source tracking. And we also have special things we do: aircraft remote sensing, real-time continuous monitoring, and we do slocum glider work in conjunction with Rutgers. So, as mentioned, our main objective is shellfish water classification. There is a program nationally, National Shellfish Sanitation Program. This is a program that any state that wants to have interstate commerce of shellfish has to follow the protocols of this national program. So there is the core. So we have a viable shellfish industry, but it's also designed to protect public health, to look at the bacterial, health of the waters, making sure the bacteria levels are low and where shellfish are harvested are safe for consumption. With that, there's also permits that we have to issue. There's other activities within the shellfish program. There's aquaculture for commercial purposes. We issue permits for that. There's harvest of shellfish from waters that are not approved that go through depuration in northern New Jersey. We permit that. We permit research programs. So there's a lot of permits that we issue. We have the water quality, the long-term ambient water quality. We have a nutrient laboratory, does a lot of nutrient work around the state. And we have our continuous water quality monitoring, in addition to microbial source trackdown in special areas and special projects, as well as shellfish Vibrio monitoring. So again, the core classified, we classify waters as approved, conditionally approved, restricted, or they could be prohibited for shellfish harvest. To do this, we actually have our field crews will collect 12,000 samples a year, and our lab analyzes all of those for fecal coliform. Our assessment team looks at the minimum of the most recent 3 years of data from every station we have around the state, which is about 1,500 active stations in any given year. To meet these standards of the shellfish program for safe waters to harvest from, you have to have a geometric mean of fecal coliform of 14 colony forming units. Now, want to point out, and a 90th percentile, you have to be below 31. Why I point this out to people, if you look at recreational bathing standards historically in the past, before they changed E. coli in freshwater and Enterococcus in marine waters, they used to use fecal coliform for recreational bathing, and it was safe to bathe in waters that were 200. So if you look, 14 and 31 is far lower than that 200 criteria. The reason why is shellfish, being filter feeders, will concentrate pathogens in their tissue. So that has to be lower than this threshold. We have restricted waters. These are the ones like up in the harbor that I was mentioning, where we issue permits for depuration. These are where you can purify the shellfish through depuration plants. They get to go to 88 for a geometric mean and 163. The conditionally approved waters that I mentioned meet approved waters, but only for a certain period of the year. So a lot of our waters are due to population increase in the summertime and impact from land use and from the bigger population, and just risk alone from more boating activity and runoff and more people being in areas. We have a lot of shoreline areas that are only open to harvest during the winter months, when the population is not there, because we know of the impacts that we get in those other seasons. So that's what conditionally approved is. And as mentioned, conformance with this program is really important because not only is it designed to protect public health, our commercial industry would not be able to ship interstate without following this program and being in conformance. Along with this, other components that I will talk about, we have biotoxin contingency plan. This is due to marine algal toxins that might impact, shellfish that could be accumulated in the tissue. So we have to have a plan for that. Then we have the Vibrio control plan, which is Vibrio is a naturally occurring pathogen that I will talk about a little more in detail in a little bit. That is naturally occurring pathogen that does cause human illness. So we have to have control plans of how to regulate the harvest and time temperature controls. And I think one thing that we wrap up all of this harvest and handling of shellfish for commercial harvesters, there's a training video that we have out on our webpage, and anybody could take it. You can get a certificate. It's really designed for commercial harvesters. They have to take the training to get their commercial shellfish license, but it teaches proper techniques about what happens with Vibrios, time temperature, what happens with this program. So it's about 10, 15-minute video, very helpful. People are more than willing to take it. If they would like to sit through it, learn more about, shellfish and the bacterial water quality and Vibrios and how to control time temperature to make it safe for consumption. As mentioned, we have some key permits that we issue. Some we work with in groups. We have hatchery nursery permits, the commercial aquaculture permit. Hatchery nurseries are where they raise shellfish that aquacultures could grow out in approved waters. But hatchery nurseries can take place in waters that are not approved. But they're limited in the size because you don't want people eating things that are coming from non-approved waters. So the size we have right now, they have to be removed at 1.5 inches for oysters and 1 inch for clams. And that's when they get removed under an aquaculture permit to approved waters, so they can grow out until they're safe to eat in those approved waters by purging contaminants. We have depuration and relay permits, research permits, because a lot of this work people want to do is in waters that are not approved. So we have to permit those activities, so there are security plans. And we have restoration permits. One of them, raising seed in waters other than approved for grout and approved or conditionally approved. That's something that we issue out, and we work closely with Reclaim the Bay is one that actually gets that permit. Then we have restoration permits for the baykeeper up in New York, New Jersey harbor. Then we have a special toxin study permit, and that's for licensed site remediation professionals if they want to use shellfish to look around potential contaminated sites in areas, if they would like to do studies if there is a need for it. From ambient water quality, we have 55 stations that we do nutrients on, and that's statewide. We do have more intensive in Barnegat Bay. That we continue on because of the intensive work and modeling efforts that were done, and all of the grants that were issued for restoration activities. We have about 20 alone in Barnegat Bay and the watershed that are done monthly, and sometimes in the summer every twice a month, every 2 weeks. We do the nutrients. We have meters that we look at oxygen, pH, salinity, turbidity. We always do lab chlorophyll, and we do alkalinity. Alkalinity is one that was something we added many years back to all of our programs, because alkalinity is also a very good, useful tool to look at the acidification process and the carbonate chemistry that takes place in water. So things you hear of ocean acidification or estuarine acidification, alkalinity along with pH is a very useful useful parameter to have. And again, we always look for phytoplankton species within these projects. We do even as part of our shellfish water samples. And the main reason for that is our biotoxin contingency plan. There are, just as you heard in freshwaters and other talks you've had that you've watched, there is algae that can produce toxin. We have them in the marine environment. In the marine environment, things like Alexandrium species that's found in the Northeast, that can cause paralytic shellfish poison toxin, saxitoxin. There's Dinophysis that's pictured here on the left that can cause diuretic shellfish poison. We have Carenia brevis, that is a red tide species from Florida that produces a neurotoxin, brevetoxin. And then we have Pseudonychia that's pictured there, the long chain, that can produce domoic acid, which is amnesic shellfish poisoning. So there's the problem with these is when the toxins get produced, shellfish being filter feeders can accumulate that toxin in their tissue, and even cooking will not destroy the toxin. So having a monitoring program and looking at all of these under the microscope, we know what's out there and if there's anything potential to produce a toxin, so we can follow up with monitoring. So this is done year round because some of these species will occur in the wintertime. So it's a year-round sampling effort. I will go in and look at our continuous water quality monitoring network. Here we have, in the marine environment, we have 8 real-time water quality monitoring buoys. We have 5 that are located in Barnegat Bay, part of our intensive work. We also have Barnegat Bay Partnership, where we assist them, where they operate and maintain 3. They come through the same web page as ours. This is a page where you can get to it in near real time. So every hour, the most recent data that's available is posted to the website. What we see at our lab is data every 15 minutes. If you plot it, you get every 15-minute intervals. It's provisional data when it's live, but this is a public available site. We also work on the Slocum glider for continuous. This is something that expanded last year to a little bit to assist with some offshore work that want to generate more data on background information offshore in deeper waters. As everybody knows, there's a lot of talk of offshore wind being constructed. There's a lot of information that we could gather from these continuous gliders on what the water quality looks like in areas. So that was work that we started to work on last year. And then we have aircraft remote sensing, where we look for algal blooms, and that's by aircraft with a special sensor on it. The sensor has a hyperspectral, it's a hyperspectral sensor. It measures the wavelengths of light. We have an algorithm in there. It takes certain wavelengths and tells us what the chlorophyll level is, so we know where you might see algal blooms. And I'll show some images coming up on what these sites look like. This is our main. This was taken off this morning so I could update it, but you'll see a lot of green dots. These green dots are where there's active monitoring buoys. You see a lot in the freshwaters. I don't know if it was discussed, but we worked with our freshwater bureau a few years back to expand a network to monitor for those freshwater harmful algal blooms. So we took what we learned in the marine environment 20 years ago and expanded it to the freshwater environment by expanding that, by working with them and helping them set up their equipment so they could maintain it. I will click, if you click on these dots at any time, you will get this first pop-up box that's in the middle. This I pulled up this morning, early this morning, so you can see at 9:01 today. This was the water quality off at a site out in Oyster Creek Channel. From the bottom, you can see a little graphing button. You could click on the graphing, and that would pop up what you see on the left of that. And that graphing, you could look at multiple parameters and what it looks like over different time frames. over the latest 5 days or latest 30 days. There's an archive if you want to go back and plot all data, or you can download data and it'll tell you how far back this data download goes to for the quality assured data. This is a tool we use routinely. We all know oxygen can get low at times after algal blooms and algal bloom die off. This is a way that we can get an idea of whether we're seeing oxygen levels drop below thresholds of, say, 4 milligrams per liter for long periods of time. You could see, looking at the data, in the morning, we had oxygen concentrations 7.3. That was very good. So we were in good shape. But we can monitor this over time. We could monitor things after change of rainfall and what the impact is. A few years back, we have a buoy in Keyport Harbor. After Ida came through and Raritan Bay flushed out, within an hour, we saw a salinity drop of over 10 parts per thousand very rapidly. And we saw salinities radically drop off fast and stay low for about a day or two. So it's a useful tool to have this. It helps with the response, but this is also a tool that the public can go to and look at what's going on. I know fishermen have used it. What's the water temperature doing? I'm going to Oyster Creek Channel. So fishermen have used it. A lot of different people use it. A lot of scientists use it. A lot of people look to see what those conditions are doing. The Slocum glider, I will talk about this. This is where you see up top. It's this yellow, glider that goes in the water. It goes from surface to bottom, uses the currents to steer. There are sensors on this of oxygen, chlorophyll, salinity, temperature. We have all of these sensors on it that'll collect the data going from surface to bottom at 1 second intervals and give us a 3D profile going from Cape May to Sandy Hook in about 3 weeks. So you can see this was a typical glider path from Sandy Hook going down the coast to Cape May. Then you see the GPS was still operational after we retrieved it, loaded into the Rutgers van, and they drove it back to New Brunswick. So you can see the track of it going down the coast. What is unique about it, it gives us a 3-dimensional view. So when you look on the side, you see the water depth. This was actually from a wintertime deployment that we had. This is the deployment we had over this winter that we put out because we wanted to start gathering data at different times of year. Because in the summertime, we get very stratified and there's cold water at the bottom, warm water on the top. We wanted to get more data to start to learn when does this break down and how long and how does it last. So this is, you can see this was oxygen percent saturation, pretty much all the way to the bottom. We were looking pretty good. We would expect that at this time of year. In the summertime, we see something completely different. So it's just another useful tool in how we can generate this data set. There's a lot of work being done at Rutgers study ocean acidification, and some of the new gliders DEP has in science and research also have pH sensors along with the ones Rutgers has to start generating more data on looking at ocean acidification, which could be a detriment to shellfish growing properly because that carbonate chemistry that they don't have in an acidic condition could cause the shells not to form very well. So there's a lot of work being done, and this gives us an unbelievable amount of data. We've been deploying gliders now and are working to assess it for about 12 years getting this type of data, and we have over 100 million water quality records at this point. So as much as we generate a lot of data, there's a lot of data to look over and to go over. This is aircraft remote sensing. This is also a publicly available page. The plane from fire service will fly 6 days a week as long as the weather is good. This was the flight from yesterday. They tried to fly today. It was a very short flight, so I didn't upload it for a visual, but this covered the whole coast. Sunday is our long flight. So we go up Barnegat Bay, across Raritan Bay, down the coast, all the way to Cape May, up Delaware Bay. We came back up, down to Mullica, and back up Little Leg, and then back into Coyle Field. So this is telling us where we might have algal conditions. And you look down and you say Delaware Bay looks a little higher along that Cape shore. That's probably why we have such great oyster growth along that Cape shore, because there's always a good food supply down there of algae. If we get into those darker reds, we use on here and that deeper orange on the scale, that's when we typically think we have a little bit of concern, where we want to go out, collect samples, and identify what species are there to make sure they're not toxin producing. So this is a great tool because we have spatial coverage, and it allows us to know where do we go send a boat to sample if we need to send a boat. This is just a zoom in view. You could zoom in. So this covers an area that's much closer to all of us, which is Barnegat Bay, and it shows us what the levels look like. And this is a typical pattern at this time of year. We can see the upper part of Barnegat Bay, although we don't see those oranges and reds. There's more widespread algae than what we typically see in Little Lake Harbor. This is a typical pattern we see. It's interesting, but it again, along with the buoys we have, this adds to it. So we have constant surveillance of being able to look at what's going on, when it's going on, what type of area does it cover. A buoy is at one point, this covers a whole area. So now we have all of those points in between those buoys. So it's a very good tool to help us know how we respond if we think we see an emergency. And I think with that, before I get into Vibrio, if we want to take any questions, Doug, I think that would be a good thing, because I'm sure there'll be more coming up after this.
Yeah, sounds good. Vibrio is an attention getter for sure. We might have something related already in the Q&A, but
yeah,
strong start, Bob. We do have some Q&A already. If others have more questions for Bob, throw them in the Q&A feature, and we'll extract even more knowledge from Bob while we got him.
Okay.
So Harvey asks, in his observations in 30 years, seeing a lot lower numbers of flounder, minnows, stripers, peanut bunker, mullet, etc., in the back bays behind Wildwood and Cape May.
Okay.
What water quality factors might be a component or are a component of this decline, do you think? Eutrophication, sewer plant discharge, mosquito spraying, other?
I would think something that people need to look at, and we've noticed, is there has been changes in phytoplankton abundance over the years. And like looking at this of the Little Leg area, where we see very low levels down here by Little Leg, we see a lot of that along the coast. If I go back to my previous slide here, if you look at this, when you get down by that lower Cape May area off in the ocean, we see very low chlorophyll levels. It's a very light blue color. And sometimes some of that productivity, you have to bring in bait fish, and you have to have that primary productivity. So we are seeing some kind of changes in that sometimes. We're not, if we saw all that green all the time, we have some kind of productivity. Too little productivity is just as bad as too much productivity. It's finding that balance. And what might be controlling that is a very difficult thing to say. It could be, sometimes you could reduce nutrients where it's not too many nutrients, there might not be enough in that location, or it could be a factor of multiple factors, such as have temperature changes, which is why the buoys are very effective for us. You know, how has that changed? Because water temp, a lot of species and phytoplankton are also temperature dependent. So depending upon whether it's colder or warmer, you can see different abundances. So it's a difficult question to answer because there could be multiple factors. But typically, when you see a lot of nutrients, you'll see a lot of productivity, which is not a good thing if it's too much. But you could go the other way and not have enough, but not having enough might not just be due to the nutrients alone. It could be due to temperature and other factors, and weather and tides. Changes in currents. What happened after Sandy? We talk about this in Little Leg with the clammers a lot. You know, what changed? Did flows change? Did shoals shift? Because that shifting will also affect all of those things: productivity, loadings from the ocean coming in. There's a lot of factors.
Yeah, a lot of factors and all connected, and a
Yeah.
very dynamic environment.
Yeah.
Thanks for that, Bob. Hopefully that was useful, Harvey. We have a couple questions also from Joe. You made some reference to this as well, Bob, but he takes it that your group and DEP is involved with the oyster restoration, or at least permitting and evaluating the work at Earl Navy Weapons Base, like
Yep.
millions of oysters growing there. Is that also a really good test case there for given all the toxins, pesticides, et cetera, in that watershed?
It is a very good test. We do work closely with them. We do get their reports. We know that they're surviving. They're doing well. It's a great case of restoration. Right now, we have some work being done in other areas with littoral society saying, as resiliency projects come forward and living shorelines, learning of what works from Earl might also be helpful with what works with some of these living shorelines too. So I think there's an added benefit of what grows where, how do they grow, how do they handle it, as well as how do we go forward with new techniques in monitoring and looking for different surveillance techniques for coverage, because one of the areas with issues with restoration is how do we do this and not have people go harvest things once they're there. So if they're in waters other than improved, it could be a risk to human health if people were to take them illegally. So there's a lot of factors that we're coming into play, but we're addressing all of those, and working with them has been very good test case.
Cool. Yes. And a related question just came in from William. He's wondering, bacterial levels have increased below the nuclear power plant since closing, he adds. Now previous areas for clam overwintering are closed. Is this an unintentional consequence of the bay water discharge not being heated, wherein bacteria may have otherwise been killed?
That we don't know. It's actually something that we've been exploring, and I'll talk about it in a little bit, but not in detail, but I could talk about it now. It could be not necessarily the water that was heated. It could be, things that we've been looking at is, did it change a little of the circulation patterns and movement of the water? That we're not really sure. But what it pointed out, though, is there were clearly non-point pollution issues that are going on. So we are actively working in Ocean Township, in those areas with Ocean Township, and looking at water quality, because the water quality issues that we're seeing are originating out of these lagoon communities and tributaries, where we have a lot of non-point source runoff. And all of the results that caused that to be suspended were collected after wet weather events. So was it that with the circulation may have been masking something going on, and we just never saw it, and when that stopped, we now see it? Or were there other issues? Because I'm kind of leading towards other issues within infrastructure, only because this is not the only area of the state that we've seen this problem with infrastructure over the last, say, 5 or 6 years. It's been expanding a little bit into certain areas. And some of our feeling is, after Superstorm Sandy, there was that rebuild period. And a lot of the focus was put on what was above the ground and getting people back in homes, not necessarily out of sight, out of mind, stormwater, sanitary infrastructure, drinking water infrastructure is all underground. And we don't know what impact might have happened, especially in areas where some of this infrastructure is 50, 60 years old. So that tidal and all of that inundation that took place may have played a factor, because we've seen this in Navesink now. We see it in Kettle Creek, Silver Bay, and that started before the shutdown of the plant. Then we saw it off there, and we see it off Westicunk Creek. But what leads us to infrastructure is we're seeing improvements in certain areas of the bay where I do know some municipalities were proactive in repairing infrastructure because they knew they were having issues, and they went ahead and repaired it. In those areas, we're seeing improvement. So I think it's more of that, I think, but it could certainly play a role because you did change circulation patterns.
Interesting. Thanks, Bob. When you have a water quality downgrade, it's after several years of data too, right? I believe.
Yeah, it's several years, and it seems to be a pattern. And if you look at the pattern, they're all either in a river or on the west side of the bay, not the east side of the bay, where you think after Sandy, most of the east side of the bay was completely rebuilt infrastructure wise because it was completely destroyed and they had no choice. Where the west side, I think it didn't take that pounding, it took that flooding. And I think we may be seeing consequences of just old infrastructure that got inundated with seawater and a lot of other issues, as well as honestly talking with some of the towns. Some of these homes went from, after Sandy, went from, your normal little ranch to a 3-story on stilts. The population has also increased. A lot of people moved down and made it their primary residence. So there's been a big shift when going from a vacation to a more year-round. And I've talked with municipalities on that too. So you add older infrastructure with a population that's increasing year-round. The homes were always there, but they weren't there all year. I think there's a lot of different factors that are coming into play.
Right on. A lot of things changed in the community for sure. Yeah. Definitely see it along the coast here. We'll do one more while we got you on this break here. An anonymous attendee asks, can you briefly explain why fecal coliform geometer has to be 14 CFUs per 100 milliliter?
All right. The geometric mean of the fecal coliform at 14. The whole National Shellfish Sanitation Program, and I'm going to give people a little lesson here. I hope people find it informative. It actually started back in like 1927. And the reason why it started was a major typhoid outbreak in the United States that were traced back to shellfish harvested from New York, New Jersey harbor. So what happened was at that time, the federal government got together, put all scientists on it, and they came up with a total coliform number that was 70. And so basically they did studies and said, at what level does the human risk from those potential pathogens get diminished? And they came up with a total coliform of 70. Then over the years, they did studies to equate as we got better laboratory techniques and got to better indicators such as fecal coliform rather than just the whole coliform group. They went to a special part of the coliform group, which is the fecal group. They did a lot of studies to equate and make an equivalent of being that fecal is part of the total, what level is equivalent of 70 to 14. So it basically dates back to studies and an outbreak that has been going, that started back in the 1920s. And that's how they got to the number at the national level. It's through scientific research at FDA with national and state scientists to design this threshold.
Wow. Amazing how far back it goes there, Bob. Really useful, hopefully for that person with a question as well. Yeah. Cool stuff. Good. I thought they might stump you there, but you got them. All right, Bob, how about we continue with the rest of your slides, and then we'll have a little more Q&A at the end as well.
All right.
Thank you.
All right, so I'm going to talk about Vibrio monitoring a little bit as one of our components, because in the worst case, there's many different species of Vibrio, and I will talk about those. But, you look at some of the headlines and they hit the news all the time, and Vibrio vulnificus gets known as a flesh-eating bacteria, although it's really not a flesh-eating bacteria. It causes blood disease and sepsis, which causes the tissue to be eroded, eaten away, but it in and of itself doesn't eat it, but it's a naturally occurring pathogen, typically found in warmer waters. But these are just some of the things that you get hit, that have hit the news. Doug, you said early at the beginning, seaweed mixing with plastics found fertile ground. So sargassum down in Florida, that was an issue. About 2 weeks ago, there was an actual case out in St. Louis of shellfish from the Gulf of Mexico. They consumed them and they unfortunately passed away from Vibrio vulnificus. There are other forms, and I'll talk about them. In New Jersey, we have been more proactive, and we've studied and test and look at shellfish tissue. So I'll talk about that monitoring, but the two main ones are Vibrio parahemolyticus and Vibrio vulnificus. Vulnificus is the one that I just mentioned that can be fatal or cause amputation and really bad infections. They're typically associated with much warmer water. So warmer water temperatures they grow. So in the winter, you typically don't see them. They will grow rapidly when the temperatures go above 70. So there are things we do on the shellfish industry. We work with our Department of Health and our marine law enforcement. We put together a Vibrio control plan as part of the National Shellfish Sanitation Program too. We put this together. It basically regulates time temperature of shellfish in the summer months. So historically, what we've seen in New Jersey is when we do get Vibrio parahemolyticus cases, fortunately, they're usually not fatal. They're usually intestinal issues. People can go to the hospital, they get pretty severe, get antibiotics. They're usually okay. You have to look at this. But what we regulate and what we've done studies on is work with our shellfish industry of how do you handle them? How long can you pull one out of the water, not ice it? How much does it grow when it starts to heat up? So if you think about shellfish being harvested and what we control from June through August, we have very strict guidelines on the commercial shellfish industry and their time to temperature requirements, whether they're an aquaculture or subtidal or intertidal harvest. We set different limits on how long they could be out there to harvest before a product has to go into cooling. We also offer out best management practices, such as rapid cooling. We did studies on that. You make an ice slurry of seawater from an approved area with ice, and you put shellfish in them. You can drop the temperature very rapidly, because what we find is typically the shellfish directly out of the water are not that bad. Most of the growth occurs after they've been harvested. And if the temperature is allowed to go up, they will multiply in the tissue and people will consume them. So the reason why our Department of Health is involved is because they regulate all of the dealers. So shellfish dealers have to have coolers that can get product down to temperature. Before they can ship them, they have to be at a certain temperature. Trucks in shipping have to be a certain temperature. So there is a whole process and trace back throughout this process. So it's very thoroughly monitored for. Like I said, we do this. We have a routine monitoring program. It really focuses on our main beds over the Delaware Bay dredge boat harvest. At this point, that dredge boat harvest from those beds is about 85% of our oyster harvest in New Jersey. Aquaculture will make up the other 15%. So we've done work on the subtidal and different aquaculture over years to come up with time temperature. But when you think of illness reporting, the more shellfish you harvest and the more shellfish that are out there, the more likely one of those shellfish is going to be implicated in an illness. And being this is 85% of our market, it's something that we monitor routinely, pretty much once a week during our peak season. Then we go to every 2 weeks and once a month when it starts to get into August, and by September, the season's over. So in New Jersey, our season basically covers June through the end of August. Most of our illnesses, surprisingly enough, typically in New Jersey have been traced to times that have been between mid-June and mid-July. And that's when most of the illness have been reported. And it's when we have seen spikes in pathogenic strains that we look for. So it's very interesting, but having that data, it helps us know where this problem might have occurred. If we get illness reports, which our health department does, they share them with us. And if we get a certain number of illnesses within a 30-day period from one area, it could be we have to close that area to harvest to protect public health. But then we have to do monitoring to see if we can open it. By us having background data to say, we already know what the level is, we might avoid a closure because we know what that level is. We also have to make sure that we're below 1 in 100,000 serving risk. So that's very important. So there's a lot of work we do behind, a lot of work health department does, and a lot of work our marine law enforcement does to oversee compliance with this control plan. So they're naturally occurring. They're there. It's not pollution driven. We've collected 2009, our greatest risk, mid-June to mid-July. We've shown most are due to the post-harvest and not related to where it's harvested from. The rapid cooling, as I mentioned, very good way, along with reducing that time of harvest to refrigeration. What we're able to do with our studies is maximize that time for industry without jeopardizing public health, because we have the data to show that what time works. So we have one of the more industry friendly and still protecting public health plans in the country. We always have VV illness. We typically have one per year. What's interesting about Vibrio vulnificus is if you're out in the ocean, it does not, we're in a high salt area. It does not thrive in a high salt environment. It likes brackish water, where Vibrio parahemolyticus has a much higher salinity range, and you'll see that more, more areas. One thing that people have to keep in mind, if you don't mind cooking your shellfish, cooking will kill the bacteria, and then you don't have to worry about it. It's when you're eating raw. That's when you run the potential issue. Other factors that come into play, a lot of people that get illnesses are already immunocompromised, have underlying conditions. Or one thing, surprisingly enough, if people are on routine antacids such as Nexium, Prilosec, things that they take prescription, you're more prone to Vibrio infection from raw shellfish. It's information that's out there. So there are risk factors. I will say in a lot of our cases, when you look through the history and the trace back, majority of people have had some underlying condition and immunocompromised issue, or have been on some kind of medication that made them more prone to it. So now I will just follow up and say there's a lot of special projects we do, and it comes back to what we're doing in Ocean Township along that Waretown section. We do microbial source trackdown, and basically what we do with this, we're trying to find the source of bacterial pollution, what might be causing it. To do this, we use an instrument, PCR. We have ARA, which is antibiotic resistance analysis, and we also have male-specific colophage. Basically, PCR, we have genetic markers to look at what the source of the bacteria might be coming from. So it could say, is it a human bacteroides source? Is it from a dog, from a cow? There's different markers that we can look at to see what the sources might be. We have, along with antibiotic resistance analysis, this is where we have panels that have 96 wells in them. And these small panels with the 96 wells, we have 26 antibiotics in different dilutions. We expose E. coli that we culture to those antibiotics. And what happens is with human waste, because we've been exposed to so many antibiotics, the E. coli from humans is resistant to most of the antibiotics on that panel. E. coli from wildlife is resistant to very few. And then E. coli from, say, domesticated animals, whether it's agriculture animals that get certain antibiotics, or even dogs and cats that get certain antibiotics over time, will be resistant to certain ones. And you can develop a pattern of where did that E. coli come from. And then we have male-specific colophage. This is a viral indicator. Colophage is shed by about 20% of the population. So it's a great indicator of a larger municipal waste system. It's very similar, to say the morphology to some of your more human viral pathogens. So when we culture this, it's just another tool. And what we like to do in a lot of these cases is run all of these on some of these samples, because all of them, if all of them tell you that it's from a human, or all of you tell you have a certain component of thinking domestic animal, if all of them guide you in one direction, having that bigger toolbox and not just basing it on one, we find has been much more effective, because sometimes not all of these are as refined as people would think, as far as determining the sources. So the more weight of evidence you have from multiple techniques, the more likely you are to be able to find and trace that back. Another part of this trace back is designing sampling. It's looking at all of our existing data. So in the case of Ocean Township, we looked at the existing data that caused that suspension, and we noticed that a lot of those were in front of lagoon communities or tributaries. Look, and then it was linked to rainfall. So what we did was we said, let's go in and look at the stormwater infrastructure of those lagoon communities and of those tributaries. And where do we have outfalls, or where do we have access points that we could collect water quality samples from catch basins during rain events? Where might, not just what is getting in, where might it be originating from? Our history of doing this over 25 years is not every outfall is the same. And you might find you could have 20 outfalls and the bulk of what's coming out is out of 3 out of the 20. This is important to know, because if you can target and do your remediation on those 3, you can make large gains and then learn what might work in other areas without trying to figure out how to redo everything. And that is a cost savings and very effective by zeroing in on where those high levels are originating from and when. So data assessment is a huge part of this. We've been working on long-term projects in the Navesink River. We're making a lot of gains. We're working in the Shark River, in both the Navesink and Shark. In the Navesink, it's turned into a community monitoring program. So we're working closely with Clean Ocean Action for years up there. We're reinstituting it this year. Got sidetracked during COVID, coming back now, where they can collect a lot of samples in areas that we need more data in on a more routine basis, that they deliver them to our laboratory. We do the analysis as a partnership. So we can start to get a better handle on where do we really need to focus the intensive effort, and where do we need to look deeper with the more intensive monitoring efforts under rain events. Shark River, there's some work being done in there by us. We have, worked with our community monitoring group up there. The Cleanup Coalition has done some work. We're looking forward to seeing some of what they've had over the years, but we continue to do work up there. We also had Kettle Creek, Silver Bay was an issue, Ocean Township, and more recently, we're going to be doing some work around Westacunk Creek in Little Lake Harbor area, where we had a suspension and some issues that we think we have an idea of what might be happening there. We also, a couple years ago, expanded that remote sensing over lakes. And it looks for phycocyanin rather than chlorophyll, so we can look for cyanobacteria blooms. So we work closely with our Freshwater Bureau and their HAB webpage, where they go out and do monitoring and do cell counts and toxin analysis. We help them track where they could use this, along with helping them expand into the buoy system. They're getting a good monitoring, doing the same thing we've done in the marine side on that freshwater side now. We've also partnered by adding nutrient monitoring, get a better understanding on cyanobacteria blooms. We work very closely with Monmouth University, Dr. Jason Adolph there. He has his whole coastal lakes network where he uses staff from and community and staff from that he has at Monmouth University to collect samples from all these coastal lakes. They're looking at the cyanobacteria. We're doing all the nutrient analysis at our laboratory, sharing it with them, so we can get a better handle on what might be driving, some of these cyanobacteria blooms and what might we do to remediate them. We're also, along with nutrients, we've also piggybacked in the Raritan Basin with USGS, Water Supply Authority. We're doing work in Manasquan Reservoir with a project doing nutrient analysis. They're doing a project on harmful algal blooms in a water supply. We're assisting them with the nutrient monitoring on that with Water Supply Authority. We do not just source track down for pathogens. We've done nitrate tracking in the Passaic River, where there were wastewater contributions under low flow that were causing a potential issue for a water supply intake. That has been remediated after our work, and we're doing much better, but we continue to watch what's going on up there. We've done things for toxins like 1,4-dioxane track down. This was something that happened on the Delaware River, originated with Delaware River Basin Commission and work that they were doing throughout New Jersey and Pennsylvania. Dioxane was originally an issue in the Lehigh, found out what the source was, that company. There are some other issues of disposal of some waste that had 1,4-dioxane in it that ended up in the lower part of the Delaware River. That's all been worked on, as well as we do statewide fish tissue contaminant monitoring for consumption advisories with our Division of Science and Research. So that's something that we will work throughout the department, where we can piggyback and utilize our efforts and our resource and boats and equipment we have. And with that, that's my contact info. And I will take any questions that people have.
Awesome. Thank you very much, Bob. Really appreciate that, and impressive work that your team and your colleagues do. What do we have? 130 miles of coastline plus all the bays and rivers, and you have a lot of territory in our ocean and bays to keep up with. So thanks for all the efforts you do to maintain our ecological and public health. We're going to have a poll now, as mentioned earlier. Amy's going to launch the poll, so if people can fill up that out to provide your feedback on tonight's seminar and what you learned and how you might use what you learned, that'd be very useful. While that's in the background, we'd appreciate, we're here for some more Q&A while we have Bob and the interest in time. We'll spend a good chunk of time here to take questions as we have them come in. So Bob, you mentioned with respect to Vibrio vulnificus that they like brackish water. They're not found in salt water, but one attendee wonders, are they found in fresh water?
There are certain Vibrios I think they're more prone and thrive. And if I look at studies that they've had on either side, on the low end or the high end, they typically are not that bad in vulnificus. Work that NOAA has done in the Chesapeake over years has shown the optimum is around a temperature of 25 or greater and a salinity of 15 is where its peak maximum is in the water column. So as you go on either side of that, it starts to tail off and come down.
Right on. And the sweet spot there are a lot of our estuaries.
Yeah, and it's funny because other Vibrios, like people don't think about that are in that family, are things like Vibrio cholera, which is, everybody heard cholera, not realizing, that's Vibrio.
Oh yeah.
Yeah, and that's something that, people, when you think about it, it's a big family with a lot of groups that can cause issues.
Speaks to the importance of also effective science communication.
Yeah,
as well. Another question came in a while ago from Joe as well. When you were talking about the continuous monitoring data and showing it for the different buoys out there, he's like, so are these data from those tools and sensors transmitted wirelessly?
Yeah, they are. They're done cellular. So back at our office, we have a computer that will basically every hour grab the most recent information from all of those buoys. So we have one for all the marine ones. We set up our freshwater guys with their own system up at their office in Trenton so they can get all of their information. Because what gets to the web is the most, in that pop-up box is the most recent reading, where the graph will give you the graph of the 15-minute intervals. The pop-up box is only the most recent. What we can see back on our display is every 15 minutes, every hour, we got that 15-minute breakdown. So it's interesting. But yes, it's cellular telemetry, and it works very well.
Awesome and cool. And so these data that are provided here, can you speak a little bit about, you spoke about the tools, but maybe also like I think what Joe means is the quality assurance, quality control for accuracy for these different sensors?
Our quality assurance, quality control, we always have to put a disclaimer. There are certain sensors that are optical, like turbidity and chlorophyll. And if there have been times that you'll see this really astronomically high reading, in the real-time data. So we have it qualified because that's not QA'd yet. But all of the calibration of every sensor that goes out, they're swapped every 2 to 3 weeks to account for any fouling issues, so we can clean them, keep the fouling down, and all of their calibration follows a quality assurance project plan. So the data that we know we're getting is good, but it always goes through a secondary quality assurance protocol. So on that page, when you see the graphing or you see that real time, that is what is happening now. So if a turbidity sensor is taking a reading and a piece of macroalgae is floating by, you're going to get this really big spike in turbidity reading that we know is not a valid point. I mean, when we go to QA it after the fact, you'll see 1, 1.5, 1.2, 1.2, 999, 1.1, 1.2, all within 15 minutes. And we know that was a glitch. So in the download section, if you go to get the historical data, that has all been through quality control after the fact.
Right on. Right on. Good to know. Good to know. Especially for those people accessing the live data.
Yep.
So Joey asked a while ago, perhaps also impressed by all the monitoring work that you and colleagues are doing here in New Jersey. Where does the funding come from for this wide range of projects and monitoring?
The wide range in the funding is from our general funds. So essentially, a lot of the department, we have funding that's kind of split up between what comes in through state revenues or what we get from statewide EPA money. The department itself, we have taken on the sole role as a state to do all of, rather than the national pollution elimination discharge, they do the New Jersey pollution permitting for point source dischargers. That is something that we do. We do the integrated report to the EPA and water quality assessment for the EPA. So the department gets a lot of money from EPA too. A lot of the equipment we will get will be from short-term, grants to buy the equipment we need. So our first 4 continuous water quality monitoring buoys, for instance, were an EPA impact grant that was for educational purposes to communicate water quality data to the public. So the first 4 we got back in 2002 were through an EPA grant. So there's a lot of different funding sources. Our sensor that's on the aircraft was an EPA grant. Our Slocum glider was through the device itself was through an EPA grant to get more consistent water quality data. We just have to fund the operation of it after we get it. But a lot of the cost is the upfront, purchase of that type of instrumentation.
Mm-hmm. A lot of partnerships and program building over time that you and your whole
and to mention, the core of our program being public health oriented with the National Shellfish Sanitation Program, we are obligated under law, and we have regulations that we are obligated to classify shellfish waters. So that's something that also, is that background funding, a lot of what we've added on has been on the back of, if you have a boat going out there doing this, we can also get this if we get the equipment. So you can you have a boat going out to get a bacteria sample, you can also get a nutrient sample. But you need the equipment in the lab to run the nutrient sample. So it's one of those, balances. How do you leverage those opportunities and get the most out of it?
Right on. Cool. An artwork that you must have mastered over your 30 years, or near mastered. Balance, like you said earlier, everything's a balance.
Yeah.
Harvey asks, recruitment is low for many species that mature in our bays and backwaters. Have you found any causes that would explain this decline in young of the year survival of finfish and shellfish?
No, I know in shellfish in certain areas, this has been something we've talked about a lot. That I'm close to. We've seen some issues in certain bays. We actually have a project I know Noah is working on with one of the growers in Little Lake Harbor, because there was a growth issue in some hard clams, even in aquaculture. I think that's something that is ongoing work. From a water quality perspective, it's very patchy. It depends where you are. If you go like where we do depuration harvest, as much as we talk about, potential toxin up in Raritan Sandy Hook Bay, I can say Raritan Sandy Hook Bay is probably one of the most productive hard clam places I've ever seen. So where you have some back bay areas diminishing, you have other areas that are consistently high. And that's some of the work that is ongoing in discussion. What is that balance? What's causing it? In some areas, we're seeing a lot of turbidity issues, not necessarily algal issues, which is causing issues with seagrasses in turbidity. A lot of this is due to the erosion, of marshlands. So there's a lot of factors, and it's certainly, I think, a lot of the upcoming projects within the Department of Natural Working Lands and resiliency. I think a lot of this is going to overlap over time to probably start seeing a difference, because I think it's more than one. I think it's more than pointing to one thing.
Likely so. We've seen some, like on the West Coast, with microplastics from rubber from car tires impacting salmon smolt survival. And stuff. So
interesting enough, when you bring that up, I was reached out to there's somebody in our group in Division of Science and Research that is actually doing work with one of the freshwater bureaus to look at that in some of the freshwater streams, upstream and downstream in locations, due to runoff and storm events.
Yep.
So there is some work already starting in New Jersey on that. That's something they reached out to us on with some of the equipment we have, and when to monitor and how to monitor. So even though it's not marine, it's something that we stay looped in on.
We had Dr. Judith Weiss as the first presenter in this series, emeritus from Rutgers University, Newark, and on microplastics. And the two largest contributors to microplastic pollution, she was saying, were fibers from washing our clothes, and then also the plastics from our tires are driving on the road.
Yeah, it's amazing. There's a lot out there, as well as, just that, combo, whichever one it is, but you have some land subsidence and you have a little rise, and you have that combination. You have wave action and erosion of marshlands, suspended solids in the water, limiting light, smothering things. There's a lot of factors, that also go along with all the non-point pollution. There are so many factors that I think that you'll find that in some areas it may be different. It may not be the same in every area, or a combination. Water temperature always plays a role too. That's a factor too. How does that change, in different areas?
Right on, Bob. I'll throw one more at you. You did a fantastic job describing all the great work you and your colleagues are doing of monitoring and other types of research here. And you had some examples throughout, but as a parting question here, are there any things that come to mind that people on the webinar, some of our participants, can do here in New Jersey to make a difference, to improve the health of and improve water quality in our coastal waterways?
Yeah, I think I always mention this, especially when it comes to non-point source pollution. I always say to people, and I've said this in the Navasink, and I say it a lot, I think one of the biggest factors we all have to acknowledge, there's a lot of stormwater inputs, there's a lot of non-point source pollution, and a lot of the times, I've been engaged with municipalities who are like, oh, the state needs to do something, or the county needs to do something. The municipality saying this person needs to do it. I think the biggest factor, I think everybody needs to realize that we're all in it together, because infrastructure wouldn't exist if we didn't want to live near the water. So we play a role in what runs off and goes into the water. So, and we have to keep in mind, when infrastructure is put in, especially in coastal communities in this, up and down the coast, when infrastructure is put in, you look at some of the towns we've done this work in, there's probably 5,000 people that live there, and the object was, people didn't think back then, it was public safety, get water off the roads because we can't have people getting accidents or drown, and to do so a lot of what was put in as we evolved and grew was no one group's fault. It was a mechanism, it was part of all of us as a whole, whether you're in government, not in government at that time, in government at that time, in government now. People in and of itself, the biggest thing we have to do is try to find a way where we can work together to alleviate these things. Because I know there was a talk early on, because I work very closely with our beach program. So last month there was a talk. I always bring it up, when one dog, an average dog, can contribute 23 fecal coliforms a day, 5 billion a day from one dog in runoff, just people not cleaning up is an issue if you're by the water. So there are little things people can do, we can do as, citizens. It drives me crazy because I walk in a park that fortunately isn't near the water, but I see all the people that don't when I do. And it's kind of like if they knew the reason why, and I think that's one of the hardest things to get at is we all have a role. What we put on our lawns, we've always heard that talk, what you put on the lawns, when you put it on. Don't put it down before heavy rain because most of it's going to wash off. You fertilize something and now it's not there. There's a lot of factors and a lot of things. What can we do as a community to reduce the amount of runoff we generate? All of that. And it has to be at all levels, and it has to be, constructive and working together is what we found up in the Navasink. And we're getting a lot more out of it by everybody having meetings and being on the same page.
Yeah, great points there, Bob. Wide ranging, but all cohesive and good suggestions from your wisdom accumulated over 30 plus years of working on this. So thank you for that, and thank you for all the knowledge you shared for the other responses and in your presentation tonight. Very useful, and the recording will live on as well. We'll get the recording posted on the Earth Day Everyday webpage and one of our extension YouTube channels, and we'll get that shared out with the people who registered. So please take a look at that, share it with your friends as well. And all the past recordings from this, where are we now? Spring into summer, and past years are on the Earth Day Everyday website. That's the wrap for all the small things with big environmental impacts. 6 of 6 webinars together here, wrapping it up with marine water quality monitoring, but we covered a lot of timely current issues in the last 6 series. So keep an eye out for more newsletters, like just went out recently on shell recycling we put out through the Earth Day Everyday program, and also more seminars to come this fall as part of these collaborations through Rutgers Extension. Thanks for all your continued participation and support. Be well, and we'll see you at the next ones. And I'll stop the recording.